You all know that climate change is having a great impact on human health, and yet there are times when natural factors can be playing a role, and often it's easy to say everything is climate change. So, this is a short article that I'm going to just read briefly. I'm not going to read the whole thing, but it says, feeling the heat, researchers struggle to convey the complex impacts of climate warming on infectious diseases. Obviously, you change temperature, you change the pathogen loading, you change humidity, water vapor, you change the vector population as shown by the mosquito here. People are moving around, and sometimes they are moving because of climate change or climate change related conflicts as it happens. So it can get very complicated. So warming is making many places more suitable for the dengue carrying mosquito Aedes aegypti. So we talked about that in the previous podcast on Aedes aegypti, but also Aedes albopictus, which have a different distribution in latitude, but nonetheless, when you have multiple vector-borne diseases going around like chikungunya, dengue, malaria, and so on, you have very complicated story to tell. So this is disease ecologist Colin Carlson says the influence of climate change on diseases is powerful but nuanced. So he's at Georgetown University in Washington D.C. In early July, on one of the hottest days ever recorded globally, Colin Carlson walked into a radio studio in Washington D.C. to answer some questions about how a warming climate is affecting infectious diseases. Cases of locally transmitted malaria in Florida and Texas, not seen in decades, had made the national news. The radio host Jen White asked Carlson whether these cases were linked to climate change. So reporters ask this question very often and very regularly, and they want almost an answer to say yes, it's climate change and it's going to get worse. If you don't give this kind of an answer and you try to be more scientifically accurate and nuanced, then often you don't get a call back. This is even for very popular and very rigorous newspapers, this can be an issue. Carlson, a disease ecologist just shy of his 27th birthday and already on the faculty at Georgetown University, was wearing flip-flops, shorts, and a heavy metal style t-shirt demanding Medicare for all. On his left hand, he had scrawled a reminder in large letters saying, "Don't swear." So you can see that in a minute he does swear. After all, the day before in his office at Georgetown, Carlson's alarm about the planet's trajectory had boiled over. He recalled a paper he had read years ago, a modeling study suggesting that if the carbon dioxide levels in the atmosphere rose above 1200 parts per million, Earth's clouds could start to disappear. It's not small potatoes. It's not this small incremental change in the way that the world works. It's not small potatoes. It's not this small incremental change. It's not the small incremental change in the way that the world works. Okay, that's a complicated sentence. Stabbing the tip of his pencil into his notebook, he continues, "It's what if our planet didn't have fucking clouds." There you go, cursing, and this published in a journal. But in the studio, Carlson explained calmly that malaria cases in Florida and Texas probably could not be blamed on climate change. This makes the story complicated, and reporters often don't like it. He clearly said that malaria cases in Florida and Texas probably could not be blamed on climate change. If cases of dengue had appeared in Washington D.C., it would be much easier to make the link, he told Jen White, the radio host, because that disease is spread by different mosquitoes. Albopictus is more common in the US. If we see something like that, it's very easy for us to say, okay, climate brought the mosquitoes and the mosquitoes brought dengue, but mosquitoes able to carry malaria have always lived in southern states. A traveler returning from abroad with the parasite in their blood is all it takes to seed a local spread. I think this is one of those weird edge cases. Carlson says this is just something that happens, but it looks a lot like things that climate change will probably bring. So you understand the subtlety there. People move around a lot, so somebody with malaria or country where malaria is endemic, or a continent like Africa or Asia, comes into Texas or Florida and he's brought the malaria pathogen and the parasite, and then a mosquito that's locally available to transmit malaria is able to do it. So nothing to do with climate change directly, right? So keep that in mind. Now let's look at disease forecasting. What will flu outbreaks ease in a warming world? So I'm going to mix the text from this paper randomly, just jumping around. From cold viruses to influenza to respiratory syncytial virus, viruses that spread through the air cause billions of infections each year. That makes it important to understand how they will respond to climate change, right? Because temperature is changing, humidity is changing, vector population is changing, and you have this virus that spread through cough and sneezing and through the air. We discussed this a lot during COVID. How far could COVID travel? Was 6 feet separation enough? And so on and so forth. But little is known so far, except that different viruses will react differently. Measles, for instance, spreads efficiently in all climates, suggesting global warming will make little difference to its transmission. That's the sickle cell virus. Okay, measles, sorry. For influenza, animal studies point to a different outcome. We can place guinea pigs in environmental chambers and unpick the dependencies, says Jessica Metcalf, a disease ecologist at Princeton University. Humidity has emerged as a crucial factor. The virus transmits best in cold and dry environments, which may help explain winter flu outbreaks as the climate warms. Allowing the air to take up more water vapor, seasonal influenza epidemics are likely to become milder in most places. So if you go from cold, dry environments to warm, humid environments, then the influenza may transmit less. But there is a catch. Today, transmission of influenza often falls to near zero between epidemics. As epidemics become less severe in a warming climate, the virus is more likely to circulate year-round in some places. That could have an effect on its evolution, says Brown University epidemiologist Rachel Baker. Without the periodic pauses, flu evolution may speed up, meaning, for instance, that vaccines might need to be updated more frequently. It's not just transmission now, just the virus itself is evolving because of the climatic factors. As for the respiratory virus that has turned the world upside down for more than 3 years, SARS-CoV-2, so far scientists have no clue how it will spread. So there we go. So we have to be careful on disease modeling, disease forecasting, because it's not just taking susceptible, infected, removed and exposed and so on and produce R factor and so on. So another example, a time of cholera. When the World Health Organization called attention in 2022 to a surge in cholera outbreaks around the globe, it listed the usual factors that favor waterborne diseases like sanitation, humanitarian crises and conflict, but it also said that climate change was worsening the situation. Cholera is caused by Vibrio cholerae, a bacterium that can produce a toxin that spreads in the stool of infected people, contaminates drinking water and food, hence water and sanitation are often mentioned. Microbial ecologist Rita Caldwell has long argued that warmer surface waters can favor emergence of the bacterium. Whether this plays any role in the large outbreaks around the globe is contested. But another climate link is clear. Foods can aid the spread by causing latrines to overflow in water sources, for instance, and droughts can boost the concentration of the bacterium in shrinking ponds and streams and force people to use unsafe water. So when there is a drought and little water is left, people congregate, and then you enhance the contact's potential spread. Climate change is making such extreme weather events more frequent, so cholera is likely to surge in a warming world, says Andrew Asman, an epidemiologist at the Johns Hopkins University. But there is little consensus on the magnitude of the effect. It is really, really hard to attribute any of the current cholera cases to climate change. Asman says, in large part because there are few good long-term data on cholera. The same caveat applies to other waterborne diarrheal diseases, which some researchers suspect will also increase in a warmer world. In other words, it seems like a good idea to always say climate change is going to make many things worse, including cholera and influenza and malaria and dengue and so on, and yet oftentimes the story is much more complicated. So here is a woman in Lagos, Nigeria, is one of the hundreds of millions of people who develop malaria each year. Warming has likely increased malaria in sub-Saharan Africa, one analysis shows, but as we said, in Texas and Florida, the story may be a little bit more complicated. It's a position researchers like Carson constantly find themselves in, caught between the nuance of now and the threat of tomorrow. So we have to understand what's happening now and see what really matters for the threat tomorrow. Defining the threat is not simple. The challenge is to do for infectious diseases what other researchers can now do for droughts or hurricanes, attribute events to climate change. The very cutting edge right now is actually trying to start doing attribution to say, for each degree of temperature change, how many more cases do we get, whether it's malaria or dengue or cholera or chikungunya or whatever, right? Says Erin Mordecai, an infectious disease ecologist at Stanford University. Okay, so this is going to get a little bit long. Maybe I should stop and come back and continue the story. But you get the point that people who actually study disease ecology and mosquitoes and temperatures and outcomes in people and vectors and so on, they have a more nuanced story to tell than just climate scientists saying climate change is going to make everything worse. Do these things matter? Yes, because scientifically you have to be accurate just in terms of calculating the risk of tomorrow by understanding today better, and sacrificing science is never a good idea and justifies the means, can get us into trouble no matter how complicated the science is. Okay, so let's come back and continue and have another podcast on this. See you.